Welcome back, mathematicians. In this video, we are going to learn about the trigonometric functions of acute angles. The 6 ratios of the lengths of the sides of a right triangle are called trigonometric functions of acute angles and are defined as follows. Let's start by understanding the labeling in our triangle here. So first, theta is labeled as the bottom left-hand vertex of the triangle, and the side that is across from theta is considered the side opposite theta and is labeled with the variable b. The side that is always opposite the right angle is the hypotenuse and labeled with the variable c. And finally, the side that also makes up angle theta in addition to the hypotenuse is adjacent to theta and is labeled with the variable a. Now the 6 trigonometric functions. The sine evaluated for angle theta is equal to the opposite side over the hypotenuse, which is equal to the ratio of b over c. The cosine evaluated at angle theta is equal to the adjacent side over the hypotenuse, which is equal to the ratio of a over c. Tangent of angle theta is equal to the opposite side over the adjacent side, which is equal to the ratio of b over a. Cosecant of angle theta is equal to the hypotenuse side over the opposite side, which is equal to c over b. Secant of angle theta is equal to hypotenuse over adjacent, which is equal to c over a. And finally, cotangent of angle theta is equal to adjacent side over the opposite side, which is equal to a over b. A good mnemonic device that allows you to remember the ratios for sine, cosine, and tangent are SO, which represents sine is equal to opposite over hypotenuse, CA, which is cosine is equal to adjacent over hypotenuse, and TOA, which is tangent is equal to opposite over adjacent. We are now ready to find the value of each of the 6 trigonometric functions of the angle theta in the figure below. Now, what we notice is that we are missing the value of one of the sides. Let's start by labeling each side, and then we'll find that missing value. So first, we have angle theta as the bottom left-hand vertex of the triangle, which means that the hypotenuse is the value of 13, and we will label that with the variable c. The adjacent side is the value of a, which we will label with the variable a. And then finally, the opposite side, which we will label with the variable b, is unknown. We are now going to use the Pythagorean theorem to solve for the unknown side, which is a squared plus b squared is equal to c squared. We can do this because we are dealing with a right triangle. Now let's replace a and c with their values of 5 and 13. Let's evaluate 5 squared and 13 squared to get 25 plus b squared is equal to 169. Now we will subtract 25 from both sides to get b squared is equal to 144. And then finally we will square root both sides to get b is equal to 12. So now we know the opposite side is a value of 12. From here we have all the information we need to find the value of each of the 6 trigonometric functions. Let's start with sine. So the sine of angle theta is equal to the opposite side, which is 12, over the hypotenuse, which is 13. Cosine of angle theta is the adjacent side, which is 5, over the hypotenuse, which is 13. And tangent of angle theta is equal to the opposite side, which is 12, over the adjacent side, which is 5. Cosecant of angle theta is equal to the hypotenuse over the opposite side. Secant of angle theta is equal to the hypotenuse over the adjacent side. And finally, cotangent of angle theta is equal to the adjacent side over the opposite side. And so these ratios represent the value of each of the 6 trigonometric functions. All right, guys, good luck.